Hi, grade 8. Here's the video notes for topic 5, hydraulics and pneumatics of mechanical systems. Hydraulic systems use the incompressibility of liquids to transfer the pressure. So some examples that's used in the jaws of life: farm equipment, earth movers or diggers, steering and braking system, flaps on airplane wings, rudders on an airplane tail, your cardiovascular system, any condition where a fluid is being pumped. And a pneumatic system uses the compressibility of gas to create high pressure. Gas is compressed. The usable force is when the gas is released. It's used in jackhammers, dentist drills, pneumatic nailers, staple guns, sandblasting, air casts for broken bones, hovercraft, your respiratory system, the pneumatic system that powers all the equipment at a mechanics store that's powered by air. And so there's an example of a pneumatic system because it's using compressed air to do the work. And in a hovercraft, they take the air and they pump it, and there's a little sort of cushion here, and the pressure builds up underneath there, and it supports the weight. And we use hydraulics in flight to control the different flaps and spoilers and ailerons. And there's a picture of the various parts that are raised and lowered using hydraulics. And we use hydraulics in our body as well. So this is where the blood vessels carry blood around, and we know the artery comes from the heart, the vein goes back to the heart, and capillaries are the intermediate where the diffusion tends to occur. And then we can combine systems as well. Though we're into topic 6, combining systems. When machines are combined, they're no longer called simple machines, they're complex machines. Most modern machines are combinations of dozens or hundreds of simple machines. A simple machine that is part of a larger machine is called a subsystem. Okay? And we can combine levers and hydraulics. A backhoe or excavator has a boom, dipper, and bucket. These rotate on gear-like parts called a slew ring. These are powered by hydraulics. Okay? And so you could see we have levers and gears, two kinds of levers, class 1 and class 3. Actually, then there's also the dipper, and there's hydraulics, all these being put together to do work. And then the Rube Goldberg machine, ridiculously over-designed machine. I showed you a video of that in class, and here is another example of it. And we're going to now go look at topic 7, machines throughout history. Just a reminder, we did these calculations with hydraulics. And so, transportation has changed to become easier, more efficient, more comfortable, faster. Also, the point where we don't have to continuously care for our transportation because they're not alive. We've made it more accessible to people as well. And so starting with the steam engine, that was basically where we started looking at big changes in machinery. Water can be heated to make steam. That steam requires more space in the water, so it increases the pressure. The pressure moves the piston, and that's attached to some sort of device to change it so we could do work. Right? And here is the one with the paddle wheel. So you could see we have the piston that goes back and forth. We have import steam. We have the export valve. And as it pushes this, it turns the wheel. And the exhaust valve switches to the other side, and it reverses itself, moving the piston back and forth. The rod of the piston is attached to gears, which turn the paddles and the wheel. Okay, and then there's turbines as well. You're going to learn a lot about this in grade 9 as well. The one I'm used to seeing is we use turbines to spin a magnet through coil to generate electricity, but it could also be used as in modern ships as steam turns turbines instead of wheels. And turbines are also found in jet engines, in generating stations as well. Steam engines require a furnace, fuel, a boiler, and the engine and piston. Disadvantage: this is big, heavy, takes up lots of room. The internal combustion engine, burning of fuel happens inside the engine, which is called internal. It says usually has 4, 6, or 8. There is also one, and the new Ford Broncos use 3-cylinder engines, but there is also cylinders up to at least 12 cylinders, possibly even more. And the pistons follow a cycle. The crankshaft converts the up-down side motion to a circular motion. And so there it is, how the internal combustion engine works. We will have these around for our vehicles until 2035, at which point in time the internal combustion engine is no longer being made for vehicles. People and machines. So development of machines brought about pleasure and comfort to our society. There's also a negative effect to the machines, pollution, displaced workers as well. The 1700s were a time when machines began to take over and more tasks that humans had originally done by hand. Two inventions facilitated this: the steam engine and making iron using coal instead of wood, which means we had more resources available to make machines. The iron for the machines and the engines to drive them led to mass production. Okay, and then because that, everyone had to move to the city, or people chose to move to the city to find work, and therefore urbanization started as well. There were no jobs out in the country. And then vehicles, we talked about that in class, the hybrid vehicles, electric vehicles, the new hydrogen engine vehicles, the traditional ICE engine as well. And as we're developing machines, our first thing we should think of is, what is its purpose? What are we building it for? And that is the end of the unit.